We are in Algebra 1. Today's date is Wednesday, March 4th. Oh, thank you for doing that, Charles. 3/4, 2020. We are on our brand new unit lesson, or Unit 9. Unit 9 looks like that. It's quadratics and polynomials, 11 lessons, 3 quizzes, 1 test. Our objective today is to do what with your imaginary card, Emma?
Add and subtract polynomials with one variable.
Yeah, and I know that we haven't really pronounced that word a lot before. Let's do the thing that we do in kindergarten where we all say the same word over and over again. Polynomial. So polynomial. Polynomial. Okay, we'll get better and better over time. Yeah, and the word polynomial, as I'm talking about it, poly, does anyone know what that means in terms of poly? Like if you're a polytheist or something? What?
Is it like more than one?
Yeah, it means many. And I think it just means many. I don't think it specifically means more than one, but it might. I mean, it's basically the same thing, right? And then nomial just means number. So this means many numbers. And look at that. I have a bunch of numbers happening over and over and over again. And if I get into its true definition, I wonder if I can do exploding dots in here. Well, since you guys are ahead, I might have time. We'll see. It's a cool visual way of explaining what polynomials are really doing. But let's start with a lot of vocab because we need it for this unit. A coefficient. You've heard this before. What is a coefficient? It's a blank that is being multiplied by a blank. Kira.
A number that is being multiplied by a variable.
It is indeed a number being multiplied by a variable. So I have this polynomial up here that we can start labeling. I will say that 3 right here, that is a coefficient. That -2 right there, or maybe you want to think of -2 and it's just a 2. That 2 right there, that 7 right there, that 1 right here, that 17. Oh, that's not really. This is not a coefficient. Everything else is a coefficient. This 2, 7, and 3 are coefficients, but this 17 is not a coefficient because there's no variable. It has to be multiplied by a variable, and there's nothing right there. Yeah, Charles.
A variable, a symbol that is equal to a number that we don't know yet.
Beautiful. A symbol. And we are very formal in our math class. So we use X and maybe some Greek letters up there like, I don't know, delta or theta. You could use heart or smiley face. Those are symbols, and those can be variables. And they're kind of fun to do, too. So if you're feeling like you want to go a little bit outside the box, and I say, what do you want to set your variable equal to? You're going to be like, I want to set it equal to 6-pointed star. Okay, what about a constant? Someone that has someone that has a card. Yeah, how's he?
A number with no variable?
It is indeed a number with no variable. So the only constant here is this 17. That is our constant.
My card.
Thank you for passing in. Ooh, okay, now we're getting into a little bit more of the nitty-gritty vocab that you might not have seen before. A term. Numbers and or a variable separated by blank and blank. These are operations that I'm looking for here. Operations. And you only have 4, maybe 6 basic operations. Anyone want to take a guess? Yeah, Emma? Ooh, it's the other 2.
Oh. Add and subtract.
Add and subtract, yep. Add and subtract. So, add and subtract are the barriers, which means anything in between add and subtract. Oh look, a subtract symbol, which means this is now a segment, that is a term. So this 3x to the power 4, that is a term. This 2x to the power of 3, well, it's being separated by a minus and a plus, so that must also be a term. I have another term, and another term. I have 1, 2, 3, 4, 5 terms right there. So think of a term as kind of like a building block, maybe a segment of the caterpillar. I don't know what you want to think of this as, but it's separated by pluses and minuses. Notice that I didn't say 7 is a term. 7 is the coefficient. X squared is not a term. X squared is part of this term. It's always separated by pluses and minuses. Okay, and finally, a polynomial. Let's say it all again on 1, 2, 3.
Polynomial.
One more time.
Polynomial.
Good. Okay, so a polynomial is a collection of one or more. Larissa? Ooh, not numbers, because I can't say 2 and 7 and 5. That actually just adds up to, what is that, 14. It's a thing that we just defined right up here somewhere. Collection of one or more. What are these segments? If I have a bunch of these segments together, that's a polynomial. What are those segments called again? One term above polynomial. You got this. What did we just define on the last line? So we're on this line. The line before this, we defined. There it is, yeah, one or more terms. And this is kind of that, I don't know, the definition. Some people will say it's 2 or more terms. I am defining it as 1 or more terms because I am aligning to Khan Academy. If I say 2, the number 2, that's technically a polynomial in Khan Academy's eyes, although I want to think of it as at least 2 terms, but I might be wrong and think that. Yeah, Charles.
Oh, I just wanted to do that.
Oh, you're already ready for the next one? All right. So we have a polynomial of 5 terms. We have 1, 2, 3 different coefficients. Are there any questions about our vocab up to now? Because I'm about to teach you how to add and subtract these guys, or at least review how to add and subtract them. All right, so I'm going to be using these words over and over, combining like terms. When you ask me, Mr. Sindel, how do I add these again? I will say, just combine the like terms. What are like terms, though? Esha.
I'm pretty sure it's terms that have the same numbers and the same variables.
Yeah, so you have one of those words right. So I think you'll have to be a little bit formal about how you say number, but I think you have actually both of them right. So the same variable and the same, so what did you mean by number?
Constant? The same constant? Or no, number like the same.
So x squared plus x cubed, I can't add those two because they have different numbers. What do I call those numbers?
So exponents?
Yeah, and the same exponents.
Whenever you could have different.
Yeah, so, and I'm going to be showing you that a little bit today. No, I guess that's not on the homework. Yeah, but x squared plus x cubed, I can't add those. Those are not like terms. But if I had something that looked like this, I had 2x squared plus 7x cubed minus x squared. Oh, now I have 2 like terms because in terms of the variable, all of these variables are x. There's no y's or q's or anything. So all the variables are the same, check. But the exponents, only the exponent of 2 and 2 are the same, so these are the like terms. This is a lonely term and has no other like terms. So I would say, okay, if I'm adding and subtracting these, if I have 2 oranges and I subtract of one of those oranges, I'm left with 1 orange, so 2x squared minus x squared is left with 1x squared. And then I have to copy down that 7x cubed again because it has no other like terms. But that's getting a little bit too advanced. I want to keep it nice and simple today, so I will come down here. We are only allowed to add and subtract, and this is kind of repeating myself over and over again. I said at the very beginning, if you ask me, Mr. Sindel, how do you add and subtract these things? I'll say, oh, just add and subtract. Quiet raised hand. Is there anyone that has their card that was paying attention? I think I'm going to have to call him Ugo. What's the thing that we've been defining up here, Ugo?
Like terms.
Like terms, yep. Thank you, Ugo. Just add and subtract those like terms. All right, so here we have example number 1. First, I'm going to annotate the like terms. If you just see the like terms, go for it. I'm just giving you this tool if you want to use it. What are the like terms with the quiet raised hand? Is everyone in now? I think everyone is in. Ulysses, are you in?
No.
Okay. You want to do it for us? What are the like terms here, Ulysses?
Would the like term be 7x and x?
It is indeed 7x and x. So I'm going to underline 7x and x. And if I have a different set of a different set of like terms, I could box them. Or if I had a different set, I could circle them. I just want to have a different way of annotating each of them. Is there anyone that can actually combine these like terms? Jay, do you have your card still? Sorry about that. Yeah, again, can you go for it?
7x plus x is 8x.
Yep, I have 8x plus 2. There it is. Box it. Question, Charles?
Is there more?
Oh, I should probably do that. Any questions on example 1? On to example number 2. Simplify these things. I think everyone's in now. Yeah, Charles.
So since you're adding each thing, you can pull them out. So it would be, you can do negative 7y plus 2y.
Yep. What is that?
Negative 5y.
Negative 5y. Perfect.
And then 6 plus negative 2 is 4.
6 and negative 2.
So 5y plus 4.
There it is. Box it. So the one thing that I want to make a note of here is whenever you have a plus sign, drop the parentheses. Drop parentheses. Which means as soon as you see a plus, you can just scribble out those parentheses, pretend they are not there. Let's try another one. Question, Emma.
Wait, so is it just if it's adding, or what if it's one for the subtract?
We're about to see that. So I do the exact same problem, but now with a minus sign. Yeah, great question. How do we do that if I don't have a plus sign? I'm not allowed to drop the parentheses. I have to create a plus sign so that I can get some parentheses. So do you guys see how these are the same problem, just one is a minus, one is a plus? So how am I going to turn that into a plus so I can drop the parentheses? Yeah, Kira?
Well, so it'd be negative 7y minus 2y, but minus is the same as plus a negative. So you just make 2 a negative number.
Yeah, so this is now a negative 2, or you can draw it up here above if you want. A negative 2y. And then what about this 2? What's happening there?
It's, I didn't get there yet.
Oh, okay. Can I give it to Wyatt?
Yeah.
What?
So if you look at it, Kira did do it correctly, but you can also look at it as the negative sign going into the parentheses, like negative times 2y, and then negative times 2. So if you make that a positive, that 2y has to become negative, and that negative just becomes positive.
There it is. Yeah. So really what I'm saying here is minus 1 times all of this, and I'm distributing a negative 1 times 2y, negative 2y, negative 1 times negative 2, positive 2. And now that I've used up the negative 1, the default goes back to a plus. So, and this is the exact way that I teach it, just as Wyatt taught. You turn it into a plus by distributing that negative, and now that we have distributed it, it turns back into a positive, and I can drop the parentheses. 100% of the time, if you ever have a negative, distribute it first, then you can drop the parentheses. If it's a plus sign, ignore it, just go ahead and drop the parentheses right away. And then from there, we have to add like terms. Oh yeah, Larissa, question?
Yeah, okay. The only thing I don't really like get is like when you're done with the problem, is it going to be a plus or a minus sign?
If you get rid of the distribution, that negative has been used up and you're left with a plus 100% of the time. Always, always. Here?
Well, I did negative 7y plus negative 2y, and it's negative 9y.
Yeah, so those two are like terms. You got negative 9y. What about the other two?
Well, that's 4.
So 6 and positive 2.
7, 8.
That's 8. Done. Box it.
But that's different, or I guess, never mind.
Yeah, and the most common error when I'm subtracting polynomials is to not distribute that negative 1 and only think the negative goes with a 2y and forgetting that this should be a positive 2 instead of a negative 2. So be warned. So in your summaries today, I should be seeing if you see a negative in between, distribute. If you see a plus in between, then drop it. The final thing, I know that it looks like we're done. I forgot to do one extra example, so let me do that now. This is going to be example 4. I'm making it up on the fly now because our homework is slightly harder than I thought. So this is example number 4 now. which is this. I'm going to simplify. I'm just going to abbreviate here. Simplify x squared minus 7x plus 3 minus 2x squared plus 3x minus 2. So this is a polynomial with 3 terms, a polynomial with 3 terms. I'm going to subtract, but if I see a subtract sign, I know what to do right away. Can someone walk me through what to do? I know Wyatt and Charles definitely know. I want to see if someone else, yeah, Ugo.
Distribute it into the mountain.
Okay, can you tell me what to write down after you distribute?
Negative 2x minus 3x plus 2.
Plus 2. Yeah, and then how do you say that term again? This, I say 2x squared. Yeah, so this should be a negative 2x squared. Yeah, perfect, thank you. And what should, before I leave you, Ugo, what should this sign be now?
Plus.
Plus, perfect. And I'll copy down this left-hand side for us as well. It's still x squared minus 7x plus 3. We have not touched that left part of the expression. All right. Now what do I do? If I have a plus sign, you know what to do. Asha?
Drop the parentheses.
Drop the
and
parentheses.
Find the like terms, which would, I think, negative x to the power of 2 is with x, yeah, that one too.
Perfect. Yeah. Can someone else find a pair of like terms? Jade?
Negative 7x or negative 3x.
Yeah, and I like how you're using the sign out in front. That is another, that's probably the second most common mistake, is thinking that it's, oh, it's just 7x. Oh, it's just 3x. Add them together, 10x. No, you take the sign in front, and you get what again, Jade?
Negative 4x.
Ooh, careful. They're both going the same direction, so I'm going to add them.
Ooh, negative 10x.
Negative 10x. Perfect. And then let's go ahead and box the last one. So I have a positive 3 and I have a positive 2, so I'll put a square around them so that I know that they are definitely different terms, or different, they're not like terms with these other ones. My final answer, Emma?
Plus 5.
Plus 5. And box it. Question, Kira.
So x squared minus 2x squared equals negative x squared?
Yep, or you can think of this as negative 1x squared. Whenever you have a negative 1x squared, we just simplify that into negative x squared. Yeah, good question. Other questions?
It's just another x.
Oh, yes, please. Can you guys give me a fist of 5 on today's lesson? How well can you do our objective to add and subtract polynomials that only have one variable? I'm getting 5, 4, 4, 5, 4, 5, 5, 4, 5, 5. Kira, what do you got? 4. All right, nice, thank you.